All right, welcome back. I hope everybody had a good break and a happy new year. If you remember, not the last time we just went over homework, but the time before we started 3.2 graphs of functions. Just to kind of review what we learned then, we learned that a graph can be used to define a function. We went through and found the points. Remember, if it's f of 0, that just means when the x value is 0, what is the y? And we got 7 for that one. Vertical line test will tell you if something's a function. So if we have a graph and I draw a vertical line through anywhere on the graph, if it hits more than one point, it is not a function. So the vertical line test says if I draw a vertical line and it hits 2 points on the graph, then it's not a function. If I drew a vertical line through here, anywhere I put that vertical line, it's only going to hit 1 point on the graph, so it would be a function. Then we went into analyzing graphs where it's increasing and decreasing. So it's increasing if it always rises as you move from left to right. It's decreasing if it's falling as you move from left to right. And it's constant if it's a horizontal line. So if I'm looking at this one, as I move from left to right, it's always going up. So this would be increasing. On this one, as I move from left to right, it's always going down, so it's decreasing. This one stays the same, so it's constant. When a function is or increasing and decreasing, it can do multiple things across an interval, like this function here, which was absolute value of x plus absolute value of x minus 2. It's decreasing from negative infinity to 0, and then it's constant from 0 to 2, and increasing from 2 to infinity, always going up now. And this is where we left off with local max and min, and I'll give you some time to write this down. So then a function f has a local max at x equals c if the graph of the function has a peak at the point where c and what our y value would be whenever we plug c in. So every point x that's around c, the y will be lower than at this point. A function also has a local min at x equals d if the graph of f has a valley at d and f of d. So all the points around that one must be higher. I realize that this paragraph can seem confusing, but it'll make a lot more sense whenever we actually look at it. So whenever I look at this graph, I can see that I have these peaks and valleys here. So up here at the top, if I pick this point here, then all the points around it are below. So this point, the points directly beside it, go lower than it is on either side. That's what makes it a local max. Same thing over here. If I pick the highest point, then all around it is low. Local mins work the same way. I can go to the lowest point, and every point around it is higher on either side. And same thing down here. And that's basically what that whole paragraph that we just wrote told us. That if I'm calling something a local max, then all the points around that point have to be lower than. If I'm calling it a local min, then all the points around it have to be higher than that point. It's really all that there is to local maxes and mins. All right, how to find a local max and min. First, we're going to graph this function, and then we're going to find all the local max and min. All right, so now if I graph this, go to my Desmos, and I'll go to my Desmos, and I'll just put this equation in. x to the third minus 1.8 x squared plus x plus 1. And I'll maximize this so I can see the graph bigger. And so I can see that as it goes all the way to the right continuously forever, it's going to be going up forever, and it's going to be going down forever. But right in here, there's going to be some local max and mins for us. And so if I zoom in on it, I can see that somewhere in here, there's going to be a point that's the highest amongst the group. And that's why Desmos is nice, because it tells us which point is the highest in the group. It's this point right here, 0.4367, 1.1767. That's my highest point in the group. So that's my local max. Over here is my local min. And just by looking at this, I can see that one of them's a max and one's a min. This one's going to be the highest point in the area because it's the highest up. This one's the lowest point in the area because nothing goes below. If I just track along this line, like if you hold your mouse down, you'll find that it's always getting higher. 1.16, whereas here it's 1.1593. Over here it's 1.1595, 7, and it's going up. So that's why this is the local min. If you wanted to do this on a graphing calculator, you could do that as well. I'll pull up the example of that. And it's fairly easy to find your local max and min on this as well. You're just going to go into y equals, graph your equation like you always would. X to the third minus 1.8 x squared plus x plus 1. Then graph. I knew something was missing. Missing an x there. That's better. So now if I want to find my local min, I'm going to go second and trace, and then go to minimum. And I can start here, push enter, and then go to the right until I know it goes higher than that. Push enter again. And you're going to see it finds our local min, which is 1.159. It says 2907, but that's just because it hasn't rounded it yet. So that gives me my local min here. And then I can do the same thing with the max. Second calc, go down to max, and I'll trace the same area. I don't want to go up where it starts going up on this curve though, because that'll give me a max there. And so then there's my local max. All right, that is it for today. We'll pick up there tomorrow and finish out this section.